In this video, you're going to learn a method or a trick for solving certain problems using a current versus voltage graph. Actually, at the end, you'll see you can use this trick for other kinds of graphs too. Let's first just review an XY axis. The horizontal axis is the x-axis, correct? The vertical is the y-axis. Now in this little simple one here, we're not using current versus voltage yet. I put height versus age. You'll note that most of the time this x-axis is time, and age is time, isn't it? Time since birth. So we have, this is called a height versus age graph. We use the y versus the x. Height versus age. And there's a line that has some data showing the relationship between height and age. Now this is actually the graph from the problem you're working on. I thought I would just use it. And here we're using current versus voltage. Current on the y, voltage on the v. Alright? Now the question is, what's the resistance? Of course, we're dealing with V equals IR, aren't we? So we've got your I here. We got your V here. The question is, what's your R? Well, here's the trick. You ready? It's easy. Okay, first, Ohm's law, V equals IR, describes the relation between VI and R. That's what the formula does. That means every point on this line must make V equals IR work. Basically, for every point in this line, V equals I times R. Alright? So, what you do is you look for a clean point. I'll show you exactly what that means in a second. Look for a clean point, substitute and solve into V equals IR using that point. Let's see how that works. When I say a clean point, look through here until you find a point where the line crosses exactly on a grid mark. See this grid marker here? There's a Y here and an X here, and that line goes right through the intersection, doesn't it? It doesn't there, does it? It's close there. If you go down here, there really aren't any until you reach right there. It crosses right on, so we'll have a nice solid value of current and a nice good value for voltage. So draw a point there, and the question is, at that point, what are the values of I and V? Well, just use the graph. I'm here, I'll go down this line, and I'll find my value of current, won't I? I is 2. I can go right down that line and find that my value of V is 7, isn't it? Okay? That's why you choose a nice clean point right on an intersection. Then you can find these two values. Now, if you end up in the middle somewhere, you gotta kind of guess. If you're right on the line, you've got nice values of, in this case, current I and voltage V. And now we can use this, don't we? Can't we? V equals IR. We've got two of them. We've got V. I put my 7 there. Put my I it goes there. And solve by dividing by 2. And in this graph, the resistance is 3.5. Can you see it? We found a nice clean point. Got the values of I and V. Plugged them in and found R. It's easy, isn't it? Sure. Let's try another one. Now this one here, I drew this myself. I gotta make it a little more complex here. I think that point there looks clean, doesn't it? Let's put a point right there. That one there looks clean too, okay? Alright, and I'll call this one point 1 and this one point 2, okay? Meanwhile, your code is this. Current versus voltage. Current vs voltage. Alright, then we'll do this. Find 1.5 there and 10 there and 0.5 and 3. Then I'll do my two calculations. The first one here, 0.1 is going to be 0.5 and 3, isn't it? Plug them in, I'll get 6 ohms. Second one is going to be, let's see, V, I is 1.5, goes there, and my V is 10, that goes there. I get a somewhat different result, don't I? Well, I drew that line. Maybe I didn't draw it perfectly. It'll be better on the MCAS. Anyway, what if your question was this way? Was this, wouldn't your answer be 6? Yeah. So even if your graph, my graph is a little off, you can still find the answer, can't you? What do you think? Would this work for other formulas too? Sure, I've got force and mass, I want acceleration. I'm running out of time, so I'll just say you do exactly the same theory, find things, substitute here into that formula, and you can find your acceleration. So that's it. So remember what we're doing here. The trick is get a clean point, substitute into your formula, and solve for R. Bye.